Hey guys, today's lesson is pretty straightforward, and we're going to go back and review some of the core concepts that we covered this year in terms of tying them into how they would work in an IB class, and in terms of using technology and knowing how to use that technology for most things that we do. So, concept of a function review. So remember that a function is a rule that matches each input with exactly one output. So x cannot repeat. All right. Also, a function is one-to-one when each output comes from a single input. So one-to-one means that it passes both the vertical line test and the horizontal line test, meaning the graph itself is a function and the inverse is also a function. And for something to be a function, it must pass the vertical line test. Okay, you might remember that. All right, so this graph right here passes the vertical line test. It also passes the horizontal line test, meaning that it only crosses at one point. This example is many to one, which means that the function or the graph itself is a function, but the inverse, or when we did the horizontal line test, it would not pass. So the original graph is a function, the inverse would not be. All right, so do the following graphs represent a function? So basically, do they pass the vertical line test? Yes, because it only crosses once everywhere. No, because this x value has two outputs. So that is the epitome of not a function. Now, reviewing domain, there are three things you should remember. You can never square root a negative number, you can never divide by 0, and you can never take the logarithm of a negative number or 0. All right, so when asked to find the largest possible domain, you can graph this and put this in your calculator. You can also realize that you can never square root a negative number. So 2 minus x must be greater than or equal to 0, always, okay? So 2 must be greater than or equal to x, because I added x to both sides. So I know you guys like when it's written with the x on the left. X must be less than or equal to 2 for this always to be a true statement. All right, this deals with rule number 2 up here. You can never divide by 0. So x minus 2 can never equal 0. X cannot equal 2. That's it. So this is the domain for this. This is the domain for this. And hopefully this is all review. All right, the range is the set of possible outputs. All right, so find the range of the following function for x is less than 0. So we're looking for a particular part, okay? You'll need to use your graphing calculator. So when you graph this on your graphing calculator, this is what it looks like. All right. Just gonna graph a little bit. If I plugged in 2, you get 0. If I plug in 1, I get 1. If I plug in, what would I have to plug in to get another positive square root in there? So I would have to plug in negative 2, because 2 minus negative 2 would be 4. So the square root of 4 is 2. So this is what my graph looks like. I want to know, I have to look at this specifically for when x is less than 0. So from here forward to the left. Okay, so I want the greatest possible range when my x value is less than 0. All right, and you can put that in your calculator and you're looking for this value right here, and it happens to be square root of 2 or 1.7, which you'll see in your calculator. All right, so that is your greatest possible range. Okay, The concept of a function is a mathematical model. Functions can often be created and used to predict the results observed in real life from a particular process. This is known as producing mathematical model process. The idea is we're not going to do anything with this specific graph, but this model does not give exact results observed in real life. You can see from the observed data points and the predictions made by the graph of the function. Just because a model is not perfect doesn't mean that it is useless. You need to understand what the limitations are. So, check at large and small values that you get a sensible result. Check whether the range is sensible in the given context, and think about how accurate the model needs to be. For example, the dosage of drugs for a patient compared to the volume of water in a swimming pool. You're looking for accuracy, or what might be accurate. So we have an example here. The population of pigeons, P of T, on an island at a time T, years after being introduced, is modeled by P of T equals 100 T squared. State 4 reasons why this model is unlikely to be perfectly accurate. All right, well, a couple things. If we were to plug in 0, we would get 0, which basically says there are no pigeons to begin with. So how can you have a model of a growth rate if you don't have a pigeon to start with? T is in years, but if we wanted to look at 4 months, 4 months is out of 12 is a third of a year. So if we did 1/3, we get a value that is 100 over 9, and you cannot have a fraction of a pigeon. I mean, I guess you could, but in the real world, we're looking for finite things. Also, as T gets large, the population grows without limit. So think about that. This is the equation of a parabola, if you think about it. It is a very steep parabola, and we're talking about positive values because we're talking about pigeons. But if I put 10 years in there, think of exponentially. If I put 100 years in there, it's growing without limit. That is not, you're not going to have an infinite number of pigeons on the planet. Also, the model does not allow for randomness. In the growth rate. Of the population. Sometimes there's a tsunami and all the pigeons disappear, or depending on the season, the population of pigeons would increase because it's mating season. So things like that, you never know. Remembering the next thing is inverses of a function. All right, inverse is where you switch the input and the output. So you switch input and output. I need to learn how to spell output. So, if I have x comma y equals f of x, my inverse will be y comma x. So you're literally just switching the places of x and y. All right, so the graph here shows the graph of a function and its inverse, and they are always symmetric around the line y equals x. So a function and its inverse are always symmetric around the line y equals x. Something to keep in mind. So here, if we were to sketch the inverse of the function, 0, 0 would still be 0, 0. This point right here is pi over 2, 1. So we would want to sketch 1 and pi over 2, right? So we're going to put that in. We're going to reflect. It's going to be like right there. And then same thing down here. It's going to be kind of over here. going to look kind of like that. And it should be symmetric around the line y equals x. You guys know I am not the like most wonderful drawer, but you're just flip-flopping x and y, okay? And you can use your calculator to do that or whatever you need to do. All right. That is about all we have for today. So good luck. Your homework should not take very long at all. It's basically like plugging in for functions, saying if something is a function, doing the vertical line test and things like that. So